Hello everyone, welcome to the channel. I am Aditi and in this video I will be discussing about the third topic in the chapter, modules, packages and libraries in Python. The third topic is libraries in Python. A library is a set of files which contains predefined code that we can use in our own programs. Let us now look at the different topics that will be covered in this video. So we will be starting off with what is a standard library. Then we will look at some examples of the standard library modules of Python. We will look at some of the most popular libraries of Python for machine learning and data science. And then we will finally understand the difference between modules, packages, libraries, and frameworks. The standard library in Python is a list of pre-written functions that comes with Python without us having to install anything externally. A standard library is a collection or a library of pre-written functions that come with Python. Some of these functions are built into the interpreter, such as print, input, etc. The rest are written in modules. To access the functions in the modules of the standard library, we have to use the import keyword. We have already discussed this in detail in the modules video of the chapter. All of the functions that are available for Python in the standard library are listed out in python.org. The Python standard library is a collection of script modules accessible to a Python program to simplify the programming process and removing the need to rewrite commonly used commands. Python standard library is very extensive, offering a very wide range of facilities. There are other third-party libraries which need to be installed separately after installing Python. Some examples of third-party libraries are Numpy, Scipy, Scikitlearn, etc. We will look at those a little later. Python standard library contains several modules for performing several operations, from sending email messages to creating a basic HTTP server. Some of the tasks that can be done using Python standard library are shown in this slide. When something is part of the standard library, it means that we can use it without having to install anything else separately. The standard library is really useful because if you're performing a common task, it is probably already available in the standard library as a function. So you can save the time and energy on writing any extra code. The standard library makes our programming experience a whole lot easier because somebody has already written the code for certain tasks that are very commonly encountered by programmers on a regular basis. And those functions are tried and tested and known to be well optimized and error-free. We will now be looking at short example codes of some of the most important modules from the standard library of Python. Let's say we want to grab a random value from a list of values. You would probably write a few lines of code to do this on your own. But this functionality is already available in the standard library. So let us go ahead and take a look at how exactly we can perform this task in very few lines of code. The standard library has something called the random module. So in this piece of code, what we have first done is we have imported the random module. We have taken a variable called courses to which we have assigned a list of random subjects or subject names. And then to another variable, random_course, we are assigning random.choice, which is a function in the random module, and we're passing courses as an argument to this function. What this does is it picks out a random element from this list and assigns it to this variable. So when we print out random underscore courses, we will be getting a random subject name from the list of courses. So this is the output. So you can see that we got a subject name. So this was randomly picked from this list. If we need to perform some common mathematical operations, instead of actually writing out code for that, we can just import the math module from the standard library. Now we can do some mathematical calculations. So we have imported the math module from the standard library. We have a variable called rats to which we are assigning math.radians of 90, where 90 is some angle value in degrees. So we're passing that as an argument to the radians function so that it gets converted into radians and it is stored in the rats variable. Next, we're printing out math.sine of rats. So whatever angle is stored in the form of radians in rats, we will be taking the sine of that angle and will be printing it out. So the output is 1 because sine of 90 is 1. Another useful module from the standard library is the DateTime module. This allows us to work with dates and times, as the name suggests. There is also another module called the calendar module. So here, there is a variable called today, and to that we are assigning datetime.date.today. So this will basically give us today's date if we run the code. Also, we're printing out this particular statement, which is calendar.isLeap of 2020, where we give some year as an argument to this function isLeap. So what this gives us is, it tells us whether this year is a leap year or not. Moving on to the next module of the standard library, the OS module. OS stands for operating systems. This gives us access to the underlying operating system. If we wanted to see what directory we're currently working in with the current script, we can use this command. So print os.getCwd. If we print this, we will get the current directory in which we're working in. The OS module has a ton of other functionalities. It gives us the ability to scan the file system, create files, delete files, and all of that. So you can see how these standard library modules give us solutions to common tasks and problems which might take us a while to write out the code for, usually. All of these modules are just Python files themselves. Python continues to take leading positions in solving data science tasks and challenges. Python is one of the most popular languages used by data scientists and software developers alike for data science tasks. Python libraries and Python packages play a vital role in our everyday machine learning. It can be used to predict outcomes, automate tasks, streamline processes, and offer business intelligence insights. There are quite a few open source libraries that make Python data tasks much easier. You've certainly heard of some of these. So here's a lineup of some of the most popular Python libraries for data science and machine learning, covering areas such as data processing, modeling, and visualization. So let us look at some of the most popular libraries in the field of machine learning and data science. Traditionally, we start our list with the libraries for scientific applications, and Numpy is one of the principal packages in this area. It is intended for processing large multidimensional arrays and matrices and an extensive collection of high-level mathematical functions and implemented methods makes it possible to perform various operations with these objects. Numpy or numerical Python is a perfect tool for scientific computing and performing basic and advanced array operations. The library offers many handy features performing operations on n-dimensional arrays and matrices in Python. It helps to process arrays that store values of the same data type and makes performing math operations on arrays and their vectorization easier. In fact, the vectorization of mathematical operations on the NumPy array type increases performance and accelerates the execution time. Pandas is a machine learning library in Python that provides data structures of high level and a wide variety of tools for data analysis. The great feature of this package is the ability to translate rather complex operations with data into one or two commands. Pandas contains many built-in methods for grouping, filtering, and combining data, as well as the time series functionality. All of this is followed by impressive speed indicators. Pandas is a library created to help developers work with labeled and relational data intuitively. It is based on two main data structures: series, that is one-dimensional, like a list of items, and data frames, two-dimensional, like a table with multiple columns. Pandas allows converting data structures to data frame objects, handling missing data, and adding and deleting columns from data frames, inputting missing files, and plotting data with histograms or plotbox. It is a must-have for data wrangling, manipulation, and visualization. Matlablib. This is a standard data science library that helps to generate data visualizations such as two-dimensional diagrams and graphs. Matlablib is a low-level library for creating two-dimensional diagrams and graphs, and with its help, you can build diverse charts from histograms and scatter plots to non-Cartesian coordinate graphs. Moreover, many popular plotting libraries are designed to work in conjunction with Matlablib. There have been style changes in colors, sizes, fonts, legends, etc. As an example of an appearance improvements are an automatic alignment of axis legends, and among significant color improvements is the new colorblind-friendly color cycle. Matlablib is one of the plotting libraries that are really useful in data science projects. It is thanks to this library that Python can compete with scientific tools like MATLAB or Mathematica. However, developers need to write more code than usual while using this library for generating advanced visualizations. Note that popular plotting libraries work seamlessly with Matlablib. Seaborn. Seaborn is based on Matlablib and serves as a useful Python machine learning tool for visualizing statistical models, heat maps, and other types of visualizations that summarize data and depict the overall distributions. When using this library, you get to benefit from an extensive gallery of visualizations, including complex ones like time series, joint plots, and violin diagrams. Scikitlearn. Scikit-Learn is a simple and useful Python machine learning library. It is written in Python, Python, C, and C++. However, most of it is written in the Python programming language. It is a free machine learning library. It is a flexible Python package that can work in complete harmony with other Python libraries and packages such as Numpy and Scipy. This is an industry standard for data science projects based in Python. Data scientists use it for handling standard machine learning and data mining tasks such as clustering, regression, model selection, dimensionality reduction, and classification. Tensorflow. Tensorflow is a popular framework for deep learning and machine learning. developed in Google Brain. It provides abilities to work with artificial neural networks with multiple data sets. Among the most popular TensorFlow applications are object identification, speech recognition, and more. This library features eager execution, which allows you to create, manipulate machine learning models, and make the debugging way easier. With TensorFlow, you can easily move your ML models into clouds on any device and on premises in any browser. TensorFlow comes with an easy-to-learn architecture. You can easily develop your concept into code and make your publications even easier. It has a solution to all of your common machine learning issues, and you can easily implement it and go on for giving your best. Keras. Keras is a great library for building neural networks and modeling. It is very straightforward to use and provides developers with a good degree of extensibility. The library takes advantage of other packages like TensorFlow as its backends. Keras is a powerful Python library. It is capable of running on Microsoft Cognitive Toolkit, PaidML, TensorFlow, and other platforms as well. This Python library features a variety of implementations from neural network forming blocks, functions, layers, optimizers, objectives, and others. Keras also features many useful tools that allow you to work with different images and texts easily. It not only supports neural networks, but also provides a fully supportive environment for convolutional and recurrent neural networks. Using Keras, you can build deep models for smartphones, both Android and iOS, or for Java Virtual Machine as well. Plotly or Plotly. This is a popular library that allows you to build sophisticated graphics easily. Among its remarkable visualizations are contour graphics, ternary plots, and 3D charts. This web-based tool for data visualization offers many useful out-of-box graphics, which you can find on the official website. The library works very well in interactive web applications. Its creators are busy expanding the library with new graphics and features for supporting multiple linked views, animations, etc. Scipy. This useful library includes modules for linear algebra, integration, optimization, and statistics. Its main functionality was built upon Numpy, so its arrays make use of this library. Scipy works great for all kinds of scientific programming projects, science, mathematics, and engineering. It offers efficient numerical routines such as numerical optimization, integration, and others in the submodules. The extensive documentation makes working with this library really easy. Scipy contains many different modules. These modules are suitable for optimization, linear algebra, and statistics as well. It makes the best use of Numpy arrays for general data structures. In fact, Numpy is an integrated part of Scipy. A supporting community of Scipy is always there to answer your regular questions and solve any issues if aroused. And lastly, PyTorch. PyTorch is a framework that is perfect for data scientists who want to perform deep learning tasks easily. It is also used for other tasks, for example, for creating dynamical computational graphs and calculating gradients automatically. It is based on the Torch library and was initially developed by the AI research group of Facebook. While in the graph mode, PyTorch provides absolute transitioning, fast optimizations, and offers a C++ runtime environment. The last topic of this chapter is difference between modules, packages, libraries, and frameworks. A module is a file which contains various Python functions and global variables. It is simply just a .py extension file which has Python executable code. A package is a collection of modules. It must contain an init.py file as a flag so that the Python interpreter processes it as such. The init.py could be an empty file without causing any issues. A library is a collection of packages. Framework is a collection of libraries. And this is the architecture of the program. So this ends the chapter of modules, packages, and libraries in Python. I hope it was helpful, and I hope you have fun with machine learning. Thank you for watching.